Once again, welcome to the world of atoms. In the previous session, we learned Bohr's atom model, then electronic configuration and Bohr-Berry rule. Today, we are going to discuss about some numbers. Numbers? What's the importance of numbers in chemistry? It's not mathematics? Yes, certain numbers have their own significant role in chemistry. They are atomic number and mass number. So today we are going to discuss about atomic number and mass number. In the previous class, you learned that different elements have different number of protons, electrons and neutrons. For example, carbon. Carbon has 6 protons, 6 neutrons and 6 electrons, while nitrogen has 7 protons, 7 neutrons and 7 electrons. Similarly, sodium atom has 11 protons, 12 neutrons and 11 electrons. Likewise, each atom is entirely different from another element. Do you know how many elements are discovered till now? It is 118 elements. All these 118 elements have their own name, their own number of protons, electrons and neutrons also. So, each of these 118 elements are entirely different from another element. But there is a proper arrangement of all these 118 elements. How is this possible? The arrangement of all these 118 elements in a correct order? There comes the role of atomic number. Let's see what is meant by atomic number. Atomic number is denoted by the letter Z. What is atomic number? It is the total number of protons present inside the nucleus of an element. It is the total number of protons present inside the nucleus. We know that in an element, the number of protons is equal to the number of electrons. So we can define atomic number in another way. It is the number of extranuclear electrons present in an atom. Extranuclear electrons. What is the meaning of extranuclear electrons? It is the electrons which are present around the nucleus. We know that in the last class we studied it. Atom has a center part called nucleus, and around the nucleus there are various shells and electrons are revolving through this various shells. So we can define atomic number in two ways. Number of protons or number of electrons. Let's see the characteristics of atomic number. Atomic number is number of protons, which is again equal to the number of electrons. See the important features of atomic number. The first one is atomic number is always a whole number. Why it is always a whole number? From the definition, we can say that it is the number of protons or number of electrons. We can't divide these protons or electrons. So never this value will be a fractional value. Always we get a whole number. So we can say atomic number is always a whole number. Then the next property is no two elements have the same atomic number. No two elements have the same atomic number because atoms of different elements have always different number of protons. As we discussed in the beginning, carbon has 6 protons, nitrogen has 7 protons, sodium has 11 protons. So different elements have different number of protons. So no two elements have same atomic number. Then we are moving to the third property. During chemical reactions, the atomic number does not change. During chemical reaction, the atomic number does not change. What is chemical reaction? You have studied different chemical reactions in your lower classes. But do you know what is chemical reaction? It is actually a chemical change. Then how does a chemical reaction occur? Usually, a chemical reaction occurs whenever an element wants stability. An element obtains stability either by giving electrons or by gaining electrons. When we studied the atomic structure, we observed that protons and neutrons are fixed in the nucleus, while electrons are always in a movement. They are energetic in nature. So, whenever an element wants stability, these electrons have a tendency to move out. For certain other elements, they have a tendency to gain electrons from some other elements. So, by giving electrons, by gaining electrons, or by sharing electrons, elements can attain stability. The main purpose is obtain 8 electrons in the outermost shell. You will learn it in detail in next classes. So, the electrons are usually undergoing chemical reaction. What about protons and neutrons? They are fixed in the nucleus. They have no role in chemical reaction. So during chemical reactions, the number of electrons may change. If an element gives its one electron to some other elements, there is a less reduction in the total number of electrons. If an element gains one electron, again there may be a change. But always the number of protons remains during chemical reaction. That's why it is said that during chemical reactions, the atomic number never changes. Atomic number is the number of proton. It is fixed in the nucleus. During chemical reaction, always electrons are undergoing changes. Then, each element has its characteristic atomic number that can be used to identify the element. We can say the element having atomic number 11. What does it mean? That element has 11 protons and 11 electrons. So we can easily identify that particular element. So from the atomic number, we can identify each element. Is it clear? All the points? Do you know how these 118 elements are arranged in a proper manner? Is it very easy? Even arranging the students in a class also is a difficult task. Then how these 118 elements can be arranged properly? Actually, it was a tedious process. But the scientist Henry Moseley developed a particular form which is known as periodic table. In the periodic table, we can see the arrangement of elements in a particular order. That order is based on atomic number. That means the element having atomic number 1, it comes first in the periodic table. The element has atomic number 2, it comes in second in the periodic table. Let's have a look at the periodic table. See, this is periodic table. Who is the first element in this periodic table? We can start from this left side. It is hydrogen. Hydrogen has, do you know the number of protons, electrons and neutrons in hydrogen atom? Hydrogen comes first in the periodic table. So that means hydrogen atom has 1 proton and 1 electron. What about the number of neutrons in hydrogen? There is no neutrons in ordinary hydrogen. The one and only one element having no neutron is hydrogen. All other elements except this hydrogen have at least 1 neutron in it. So the atom which comes first in the periodic table is hydrogen. Then the second element is placed at the extreme right corner of the periodic table. Which is that element? It is helium. Then comes lithium, beryllium, boron, carbon. The list continues. So all the 118 elements are arranged in a proper manner. If we observe this periodic table, we can see that the number of protons is increasing one by one. Hydrogen has 1 proton, helium has 2 protons, lithium has 3 protons. It continues. Here, the left side. This left side elements are metallic elements. Sodium, potassium, calcium, magnesium, all these are metals. While the other side, that is the right hand side of the periodic table, contains gaseous or non-metallic elements. And in between the metals and non-metals, we have transition elements, the blue colored elements. They are transition elements. We have a transition of metals to the non-metals through this transition elements. So this is periodic table. In periodic table, elements are arranged in the order of increasing order of atomic number. It is developed by scientist Henry Moseley. In addition to this atomic number, we have one more criterion for identifying an element. It is mass number. Do you have any guess about mass number? It is given on the board, but any idea? Where is mass of the atom concentrated? It is inside the nucleus. Then who are the residents of this nucleus? Protons and neutrons. Then what is mass number? Is there any role for electron in the atomic mass? No, we studied that in the beginning. We studied electrons have negligible mass. So, there is no contribution from the part of electrons to the mass of atoms. The mass is completely contributed by protons and neutrons. So, we can define mass number as the total number of protons and neutrons present in the nucleus. And this mass number is denoted by the letter A. See the equation? Mass number A is equal to number of protons plus number of neutrons. So, by using this atomic number, mass number and one more feature, it is symbol. By using these three notations, atomic number, mass number and symbol, we can represent an element. See how we can represent the element. X, Z, A. We will read it as Z, X, A. Where Z is the atomic number, X is the symbol and A is the mass number. Then what is meant by symbol? Symbol. It is actually the short form of the name of an element. For example, hydrogen. When we will write it as hydrogen in words. But we can write it in short by using the letter H. Carbon is written as C. Oxygen is written as O. Nitrogen, N. Phosphorus, P. So each of the element has its own symbol. For most of the elements, the symbol is taken from their English name. Carbon takes its symbol from C. Nitrogen, N. The first letter is taken. But in the case of some elements, more than one element start with the same letter. For example, carbon, calcium, then chlorine, they all have same starting letter. In such cases, we take the second letter or the most dominant letter for its symbol. Calcium, the symbol is Ca. In that case, second letter is taken for the symbol. Then for chlorine, which is the second letter? Chlorine, CHLORINE. The second letter is H, but H is silent there. The dominant letter is L. So we will take the symbol as Cl. Chlorine symbol is Cl. Calcium symbol is Ca. Carbon symbol is C. Nitrogen, N. Neon, Ne. Hydrogen, H. Helium, He. So there are many criteria. For some other elements, their English name is not considered for symbols. Their Latin names are taken for their symbol. For example, sodium. The Latin name of sodium is natrium. Already we have N for nitrogen. So we will take the second letter from the name natrium. Na. That is why the symbol of sodium is Na, not S, S or SO. Similarly, potassium. Potassium, its Latin name is Kalium. Its symbol is K. No other elements have symbol K. So we can take K as the symbol of potassium. So for taking symbols, we use many criteria. By using symbol, then atomic number and mass number, we can easily represent an element. Also, we can easily calculate the number of subatomic particles present in the element if we know the atomic number and the mass number. See these equations. Number of protons is equal to the atomic number. It is again equal to the number of electrons. Or number of neutrons is equal to mass number minus atomic number. So by using these equations and also by using the complete representation of elements, we can calculate the number of subatomic particles present in an element. Let's see some examples. Let's take an example. 1H1, the first element. We can read it as 1H1. We are starting from the atomic number. 1 is atomic number. The superscript 1 is mass number. Did you get idea about the number of protons, electrons and neutrons? Yes, we can write number of, in this case, number of protons. What is number of protons? It is the atomic number itself. So we can write the number of protons present in ordinary hydrogen is 1. Proton is equal in number of electrons. So what would be the number of electrons? That's also 1. Electrons also is equal to 1. Then what is the number of neutrons? From that last equation, we can write number of neutrons is equal to mass number minus atomic number. Here, so we can write number of neutrons. The mass number is 1, atomic number is 1. 1 minus 1, that's equal to 0. So what is the number of neutrons in ordinary hydrogen? It is 0. Let us take one more example. 11. Which element is this? Na. Which element? Sodium. Sodium is Na. 11 Na 23. The mass number of sodium is 23. Can you write the subatomic particles in your book now? Number of protons. Number of protons is equal to the atomic number. That's equal to 11. What about the number of electrons? Electrons is equal to, that's also same as the number of protons. So, electrons also 11. Then what about the number of neutrons? Neutrons is equal to mass number minus atomic number. Mass number is 23, atomic number is 11. So, we will write 23 minus 11, that's equal to 12. How many neutrons are present in sodium? Sodium has 12 neutrons. Do you remember the postulates of important features of atomic number? We displayed the points on the board. The last point was the atoms of same elements always have same atomic number. That means if we consider 100 hydrogen atoms, all these 100 hydrogen atoms have same atomic number, but there may be a change in mass number. If we observe the total amount of hydrogen in the atmosphere, we can see that all the hydrogen atoms have same number of protons, but their mass number is different. We studied now that hydrogen has atomic mass 1. But for some other hydrogen atoms, when we observe, it is observed that they have a mass number of 2 and 3. Not only hydrogen, more other elements are present in such conditions. Such elements are called isotopes. Now we are going to the next topic, isotopes. See the definition. Atoms of the same element having same atomic number and different mass numbers. Atoms of the same element having same atomic number but different mass number. Why do they differ in their mass number? They have same number of protons. So their number of electron also is same. Then what may change? This is because they have, all these elements have difference in the number of neutrons. See the characteristics of isotopes. Isotopes differ in mass number because they have different number of neutrons. The chemical properties of isotopes are similar, but their physical properties are different. Why the isotopes have same chemical properties? I explained to you that during chemical reactions, only electrons are undergoing a change. In the case of isotopes, in all the elements, the number of electrons is same. As a result, all the forms of isotopes have same chemical property. Hydrogen has 3 isotopes. All these 3 isotopes have same chemical properties, but they may differ in their physical properties. See example, the first one, 1H1. This is ordinary hydrogen. It's also known as protium. See the arrangement of particles. Proton inside the nucleus. Only proton is present in ordinary hydrogen. It has only 1 electron. Then the next is the isotope of hydrogen is 1H2. 1H2 means this element has 1 proton or 1 atomic number, but its mass number is 2. Mass number 2 means in addition to 1 proton, it has 1 more neutron. See the arrangement of particles. Proton, 1 proton and 1 neutron. As it has only 1 proton, it has 1 electron also. The electron is revolving around the nucleus. See the third isotope. It is tritium. The name of the second isotope is deuterium. Deuterium. Then third one is tritium. Tritium has symbol 1H3. It also has same atomic number as protium and deuterium, but its mass number is different. Its mass is 3. It has 2 neutrons and 1 proton. So isotopes are atoms of same element having same atomic number but different mass numbers. Okay, we have here the uses of isotope. Isotopes are very important in our life because they are used in many areas of health. See the properties. Uranium. Uranium-235. It's an important isotope of uranium. It is used in nuclear reactors. Then cobalt-60. An isotope of cobalt. It is used in the treatment of cancer. Similarly, phosphorus-32. Phosphorus-32 is another important isotope of phosphorus. It is used in leukemia. What is leukemia? It's also a type of cancer, blood cancer. For the treatment of blood cancer, we use this isotope phosphorus-32. Then iodine-131 for thyroid problems. So iodine-131 is used for the treatment of thyroid problems. Then in addition to this, we have many other different uses. Example, carbon-14. Carbon has many isotopes, carbon-12, carbon-13, carbon-14, etc. Among these isotopes, carbon-14 isotope is used in carbon dating. Do you know how the age of fossils are calculated? By using this isotope. That process is known as carbon dating, the technique of finding the age of fossils. Then, many other elements, isotopes, are used for identifying leakage of underground pipes, oil pipes, water pipes, gas pipes, etc. So we are using isotopes in many areas in our life, in our industries, and also in healthcare industries. Average atomic mass. When we studied mass number, we observed that all the mass numbers are in whole numbers. But in the case of isotopes, there is a difference. If an element has isotopes, their atomic mass may or may not be a whole number, because they depend on the percentage of occurrence of that particular isotope in the nature. For example, chlorine. This is the symbol of chlorine. Chlorine has two important isotopes, 17 chlorine 35, also 17 chlorine 37. These two are important isotopes of chlorine. What would be the mass of chlorine? Is it 35? Is it 37? Or its average value? No. When we write the symbol of chlorine, we will write 17 Cl 35.5. 35.5. It is 5. Why this fractional value for mass number? This is because this chlorine 35 present in nature in 75%. 75%. While chlorine 37 is only 25%. So when we calculate the mass number of these elements having isotopes, we must consider their percentage of occurrence in nature. So we will calculate this as 75 into 35 divided by 100 plus 25 into 37 by 100. Then we will get 35.5 U. So for most of the elements, if they have isotopes, they have a fractional value for mass number. We have one more kind of elements. They are called isobars. What is iso? Iso means same. Baros means, in Greek, baros means weight. So what would be the meaning of isobars? Elements having same mass. So we have such kind of elements also in our nature. That means even though their atomic numbers are different, they have same mass numbers. We can define isobars as they are atoms of different elements having different atomic numbers but with the same mass number. They possess different physical and chemical properties. In the case of isotopes, we observe that isotopes are similar in chemical properties because they have equal number of electrons. But in the case of isobars, they are different in both physical and chemical properties. See an example. 18 argon 14. 18, atomic number of argon is 18. It has a mass of 40 U. Then potassium. Potassium has atomic number 19. Its atomic mass is 40. Similarly, calcium. Calcium atomic number is 20, but its mass is 40. See, three different elements. These three different elements are different in their atomic number. That is why we call they are different. But they have equal number of mass. Equal mass. Such elements are called isobars. Clear? Okay. So then what we studied today? Today we studied only atomic number, mass number, isotopes, their uses and isobars. I hope all of you have understood it clearly. Now you have some assignments. The mass number of an element is 15. It contains 7 electrons. What is the number of protons and neutrons in it? What is the atomic number of this element? We discussed some examples. From the atomic number, mass number, we can calculate the number of subatomic particles. So write this question and write its answer. Then another one. An element has an atomic number of 11 and its mass number is 23. Which element? Okay. What is the arrangement of electrons in shells? If we know the atomic number, we can easily represent their electronic configuration by following Bode-Bury rule, 2n square rule. Then state the nuclear composition of an atom of this element. Nuclear composition means what is the number of neutrons and protons. Here one more. From this symbol, 15p31 state mass number of phosphorus, atomic number of phosphorus and electronic configuration of phosphorus. So by this we conclude the session, and in the next video we will meet again with another important topic, valency. Thank you.